Hello everyone. So this is your Monday asynchronous lesson for algebra. We are now on section 7.5. So get out your notebook, get out a piece of paper, wherever you're going to be doing your notes today. Please title it. This is 7.5. We're moving on to solving polynomial equations in what's called factored form. Our learning objective, which is that I will bot right below, you don't have to write down, but it is what you want to keep in the back of your mind, is what we're going to accomplish today. And we're going to use what's called the zero product property to solve polynomial equations. Now, this is a very foundational section when it comes to the rest of the year, because in some way, shape, or form, every question in the rest of the chapters will come back down to this section. So that might sound a little like scary, but you'll realize this is the easiest part. So I kind of gave you some examples of what a factored form would look like, and then what we're used to seeing so far is called standard form. So factored form. This is when you have two expressions being multiplied together. Again, I know that's multiplication because first of all, looking at those examples under factored form, there isn't a plus sign or a minus sign or a division sign connecting the two expressions. There's nothing specifically written in, which we assume is multiplication because multiplication is always invisible. And so what we have are just examples of expressions, which is really, in the first one, it's a monomial times a binomial. In the second example, we have a binomial times a binomial, which is the most common that we'll end up working on. But we're just trying to make it so that two expressions are being multiplied. Now, I don't want any constants, I don't want any coefficients, being added or subtracted or being multiplied in front or behind these expressions. So we will see an example of where that happens and how we get rid of it. Because in order to actually solve a problem, we have to have factored form on one side of the equation, meaning nothing else besides two expressions. Standard form is what we've been working on the last 4 sections. And this is when from left to right, your exponents go from big to small. So I gave an example of a binomial and a trinomial, meaning something that has 2 terms versus something that has 3 terms. So this is standard form. Eventually, we will learn how to take standard form and go to factored form. But for all of our problems today, our problems will already be in factored form, so it makes our life a bit easier. If at any point I go too fast and you just need to pause to copy stuff down, please do that. I am going to start to scroll a little bit, and we're going to talk about what is this zero product property. So, zero product property is really a process versus that we follow. It is related to a property of just multiplying things to equal 0. So what I did first was kind of write out the process of how do we use the zero product property, and then I'll explain pretty much what is it and why does it work. So when we use the zero product property, just how we solve any polynomial equation, which is literally the equations that you will have for the rest of the school year, our first step is to make sure the equation is set equal to 0. Now that part should be pretty easy. Then, number 2, says the other side of the equation needs to be in factored form, which again for this section will be pretty easy because all of our problems will be ready to go there. Then, step 3 says set each product equal to 0 and solve for the variable. Okay, so this is kind of actually relating a little bit to solving equations from chapter 1 that we learned at the very beginning of the year. But let's talk about really what is a zero product property and why does it work. So the zero product property means 0, something's going to equal 0, product means in some way we're multiplying. So the mathy way we're going to talk about it is that we have this product AB, which is really A times B. And I'm saying this equals 0. Well, in order for this statement to be true, when we're talking about A and B being numbers, well, in order for A times B to equal 0, one of these 3 facts has to be true. Either A equals 0, B equals 0, or they're both equal to 0. Now, this is a very mathy way to write it, so let me just show you an example. if I had, let's just say 2x equals 0. And I said, what does x have to equal? Well, hopefully remember the fact that anything times 0 has to be 0. So if I know I already have a 2, that's kind of like my a, then automatically x should equal 0. That's the only way this would be true, because 2 times 0 is 0. Now, I could have something like y, and I'm going to write this weird, and I know, y times 1/4 equals 0. And yes, this is not the traditional way I would write this, but just for sake here to kind of show you a and b. So in this case, what f is having to figure out what y is, we have to know something times 1/4 equals 0. Well, we should again remember anything times 0 is 0. So that automatically means y has to equal 0. But then we can come across this option of something x times something y has to equal 0. Now, we already kind of saw that, well, and to make this true, either x has to be 0, y has to be 0, but you can also have both numbers be 0, because 0 times 0 is 0. So we have these three options that just make this true. So we're just zero product properties, just saying, hey, two things are getting multiplied, their answer is 0, so either one or both of the numbers are 0. That's the only way it's true. Now, when we're doing our problems, we're going to assume both of them have to end up equaling 0. Now, this might sound kind of weird, a little like, I don't know what you mean, Miss Horner. So let's actually see some problems, and you'll realize it's pretty easy. Oh, wait, one more definition. Sorry, last definition, and then you'll see the pretty easy problems. So this is new vocabulary. We have something called roots, and I wrote /zeros / x-intercepts because they are all the same words. They all mean the same thing. I shouldn't say the same word. They all mean the same thing. So if you see a question that says, what is the root of a polynomial equation? That really is asking you, what is a 0? And you were probably like, well, I don't know what a 0 is. And well, 0 is the same thing as an x-intercept. And so when you see the word root or 0 in a problem, it's really asking you, what is the x-intercept? Where does our graph cross the x-axis? And they are just otherwise known as the solutions to a polynomial equation. And so really in every problem, we're trying to find where's our graph going to cross an x-axis. Sometimes we'll do it graphically, and most often we'll do it algebraically, which is what we're going to learn today. Now, enough like talking about mathy-like things. Let's actually do some math. Let's go to example 1. We have x times the expression x plus 8, and I'm saying it equals 0. Okay, this is a product. So this is actually how we apply the zero product property. I have two things being multiplied together, and the answer is 0. So that would mean either x has to equal 0, the expression here, just x, or x plus 8 has to equal 0, or both. So we're going to assume both could equal 0. We're kind of just going off of covering our bases. The left side of our equation is factored form, meaning I do not have any coefficients, so any numbers in front of my expression being multiplied, and I don't have anything being added or subtracted afterward. So we're okay. This is factored form, and one side equals 0. So according to those 3 steps, we can actually move on to solving this, which is saying take each product, so in this case x is 1, and we set it equal to 0. And then we take the expression x plus 8 and set it equal to 0. So we break this apart. We're pulling it apart to be 2 separate equations. They are both set equal to 0 because when multiplying, something times 0 is always 0. So we have to account for both options. Now what we have to do from here is actually solve for the variables. So we are going to have 2 answers. On the left, x is already by itself, so if I had to write what my answer is going to be, I can automatically say this one because there's x equals 0. There's nothing I could solve for. X is already by itself, so I know that's one of my answers. But on my other expression here, I have x plus 8 equals 0. Well, this is a one-step equation. To get x by itself, you subtract 8. So this says x equals negative 8. And that would represent my other answer. Now, there are many ways you can write your answer. I personally like to write it out separately, like x equals 0 and x equals negative 8. Or you could just write it as x equals 0, and then you could write comma negative 8. This is just saying there's a list when I'm having my comma, meaning there could be other answers. They're not, but it's one way you could write your answer. Either is fine. Technically, what we just found was an intercept. So a third option to write your answer would be writing them as coordinate points, where you have an x, your x value goes first, and then you put y value of 0. Oops. That would be another way you could write your answer. Truthfully, I would just stick with either the first or second options for now. Let's try another one. This is B. We have the expression x plus 6 times x minus 8, and it equals 0. The only way this could equal 0 is if x plus 6, that expression simplified down to be a 0, or the expression x minus 5 simplified down to equal 0. Well, in order to see if this is going to be true, we'd have to figure out what is x, what makes the statement 0. Now, some of you might be able to automatically look at these expressions and say, oh, I know what the x should be on the left, and I know what the x should be on the right expression. That's fine. I still recommend getting into the habit of showing your work by showing the one-step equation process, just in case you make any, brain farts and you do too much in your head. Sometimes things get jumbled. So the appropriate way to show your work is to pull these two expressions apart. So it's kind of like you're making two mini problems, and you have x plus 6 equals 0, and x minus 5 equals 0. Two mini problems, both of them you need to solve for x. Both of them are a one-step equation. In order to get x by itself on the left expression, you subtract 6. And we have potential answer of x equals negative 6 on 1. For the second expression, to get x by itself, you add 5 to both sides. And we'd have x equals positive 5. Those are our two answers. Now, some of you might be wondering, well, how do I know 100% for sure this is my answer? Well, we can check this. Plug it in. So we know our x equals negative 6 is what we could have plugged in for one value of x. So we can do two mini checks. One problem where I plug in x value of negative 6, or one problem where we have an x value of 5. So I can check this. If I plug in an x value of negative 6, anywhere I see an x, I'd have negative 6 plus 6 times negative 6 minus 5, and my hope, question mark, is that it equals 0. Well, negative 6 plus 6 is 0, times negative 6 minus 5 is negative 11. Does this equal 0? Yes, because anything times 0 is 0. So I know that could be a potential answer, but we had two potential x values, so you have to do two checks. So the next option would be where I see an x value, the variable x, I'd plug in the x value of 5. So then I'd have 5 plus 6 times 5 minus 5. And again, hopefully, question mark, it equals 0. 5 plus 6 is a positive 11 times 5 minus 5 is 0. Again, does this work out? Yes, because anything times 0 is 0. That's how I know both my answers are true. All right. So I'm going to do one more for this, and then I'll have you try it. All right, so example 2. We have the expression 3p plus 6 quantity squared, and it equals 0. Please remember from your 7.4 lesson that when you see something like this where you have a quantity squared, that does not mean 3p squared plus 6 squared. It is not a distributive property of an exponent of 2. This is saying I actually have 2 of these expressions. So when you run across a problem like this, we rewrite it so that you have 3p plus 6 times 3p plus 6. That's what the exponent is really telling you. The base is being multiplied by itself twice. So I should have 2 of the expressions 3p plus 6. Now, this is in factored form, and we can solve the problem. Well, hopefully you're kind of wondering right now, are we going to have 2 different answers when you have the same expression? Well, the answer is no. So I have the same exact expression. I will only have the same exact answer. So that means in this case, you actually only have 1 answer, and that's okay. I will still show work to break this up, just to be 100% clear. Zero product property says take the 2 expressions, split them up into 2 mini problems, where one side is set equal to 0, and the other side is the expression from the problem, which in this case is the same problem. So in order to solve for your variable here, this is a 2-step equation, where you first undo the constant, which is the plus 6, with subtraction. So I'm going to subtract 6 from both sides. Here's where a lot of people tend to like the fairness bar, so let me draw that in. This leaves me with 3p equals negative 6. To get your variable p by itself, we undo the secret operation of multiplication with division. We divide by 3. So you get p equals negative 2. Now, I can do that exact same process because it's the same problem on the right side. And what you will see is that no matter what, we get the same answer. You don't write it twice. You just write it once. There's no reason to write it twice if you have the same answer. So if I had to be extremely clear, the answer is only p equals negative 2. And that is it. Just write it once. No need to repeat yourself if it's not necessary. All right, it's time for you to try one. Try B. You have the expression 2y times y minus 4 equals 0. It is in factored form. Split it up, solve for your variable, pause it, and then unpause when you're ready to check your answers. Alrighty, so let's see how you did. You should have broken up 2y to be its own problem, and then y minus 4 to be its own problem. So you should have had 2y equals 0, and then y minus 4 equals 0. And when you solve for your variable, on the left, 2y, well, to get 2 by itself, it's undoing a secret operation of multiplication, or you could logically think about this without any work, but 0 divided by a number is okay. You do just get 0. On your second expression, y minus 4 equals 0, to get y by itself, you add 4, and you get y equals 4. So you should have 2 answers here, y equals 0, and y equals 4. Hopefully that went okay. I'm hoping by now you're starting to feel, not too bad about this stuff. I am going to do one more for you, and then I'm going to show you, I don't really want to call it a challenge, but one that looks a little bit different. Oops, let's see. All right, so with C, I'm going to give you x minus 9 times x minus 1 equals 0. Pause the video now. Try to find your answer, or your x-intercepts, or your roots, or your zeros. It's all the same thing. Okay, let's see how this one went for you. Again, you were setting both expressions equal to 0. So you're splitting them up, where on one you have x minus 9 equals 0, and another mini problem you have x minus 1 equals 0. Both of them are one-step equations. So on the left, to get x by itself, I'm going to add 9 to both sides. So you should have gotten one answer that's x equals 9. And with the other expression, we would add 1 to both sides to get x by itself. We have x equals 1. So those should have been your two answers. Hopefully that went okay. And I'm hoping you're starting to see this is actually pretty easy. And in some way, shape, or form in the future, all of our questions will come back down to this section. Isn't that neat? Okay, I just have one more. This is D, and I wanted to show you one that looked a little ugly. This is the last problem. We have 1/4 times the expression y plus 4 times the other expression 1/4 y minus 8, and it all equals 0. Well, this would look like a normal factored form, except for this 1/4. So this 1/4 is kind of throwing it off. In order for this to just be a nice factored form, you cannot have any coefficients, meaning a number in front. So we actually need to get rid of the 1/4 first and then apply the zero product property. Well, some of you, your instinct might be distribute. Well, you can do that. It's fine. You'll get the same answer no matter what. I personally don't want to do more work than necessary, and distribute a property is more work. So another way we can get rid of this 1/4 without distributing it is remembering that 1/4 and really everything here is being connected with multiplication. And so I know I can undo it. I can move things around. And so I'm going to undo this multiplication of 1/4. Now, when I'm multiplying with fractions, when I undo it, I like to multiply by a reciprocal. A reciprocal is an upside down fraction. And what it does is cancels it out. And so what I'm going to do is actually multiply both sides by the reciprocal, which is upside down version of 1/4, which is a whole number of 4, but I'll be extremely clear. It is 4/1. And if I do that to both sides, what will happen is that the 1/4 and the 4/1 cancel each other out. And the only thing we're left with is a factored form, y plus 4 times 1/2 y minus 8. And this still equals 0. Why? Anything times 0 is 0. So even if I have 4/1 times 0, it's still 0. Now we can break this up and apply the zero product property, which says split this into two problems. I'm like, okay, I can do that. So I got one problem where I have y plus 4 equals 0. Then I have another problem where I have 1/2 y minus 8 equals 0. You have a little fraction here. It's okay. I want you to pause the video now and try to solve both expressions, please. Okay, well, let's see how you went. So on the first one, it should be pretty easy. To get y by itself, you would subtract 4 on both sides. So you get y equals -4 is one answer. Now, the one with the fraction, let's see if you remembered how to deal with it. To get y by itself, I first add 8 to both sides because we undo addition and subtraction first. We get rid of the constant. This leaves us with 1/2 y equals a positive 8. Well, right now I have 1/2 times y. So I can undo this with division, but then that would be division of fractions, which implies copy dot flip, which is gross. So let's use the trick that I used above. To undo a fraction, our trick is to multiply by a reciprocal. The reciprocal of 1/2 is 2/1. So you should have done something similar to this and hopefully multiplied by 2/1. If you didn't, you'll still get the same answer if you apply copy dot flip. But the 1/2 and the 2/1, they cancel each other out. And it leaves us with just 8 times 2/1. Well, let me just show some work over here. 2/1 is the same thing as a whole number of 2, so it's really just 8 times 2, and that's 16. So my two potential answers here are y equals -4 and y equals 16. And that is it. So hopefully, this works out. You feel not too bad about this. If you have any questions, reach out to your teacher for extra help on this assignment. This time your homework is on Schoology. It's not on Delta Math. So check your Schoology site for it. There are 10 questions and you guys have 2 attempts. Please remember that late work means you don't get full credit. And this Schoology assignment is officially due on Friday, February 12th. That's it. Have a good day.